first thing you have to be able to do is you have to be able to write a KSP expression, solubility products, so they're mainly insoluble. So if we take Ag2CO3 as a solid, when it does break up slightly, it's going to be 2Ag plus CO3 2 minus, and then when I go to write the expression, remember no solids, so that just means my KSP is going to be equal to Ag to the second, CO3 to the first. And that would be my KSP expression for A. When I go to do B, it's going to be CeIO3 parentheses 3. That's my solid. That's going to break up into Ce3 plus IO3 minus, but there's 3 of them because note the subscript. Remember, that's what helps you determine the number of ions it's going to break into. We don't include that in the expression, so then it's going to be KSP is equal to the concentration of Ce3 plus and IO3 minus cubed. There's my equilibrium expression for that. Last but not least is BaF2 is a solid. It is going to break up into Ba2 plus 2F minus. And I don't include solids in the equilibrium expression, so my KSP is going to be equal to the concentration of barium times the concentration of F minus. The coefficients become exponents. That's the first step. Next question. Use the following data to calculate KSP. So when they ask us to find KSP, they'll usually give us grams and liters, and we have to find molarity. This problem's a little more easier than usual because they're giving us the molarity. So all we have to do is write the expression. So what I do, the easy way to do it is I'm going to write Ca. I always do it in 2 steps. Ca2O4 is a solid. It's going to break into Ca2 plus C2O4 2 minus. And then if I do a mini ice table, this is 0 and 0 plus S. Ultimately, I get S and S. Then I take the S value and I add it to the E line before I go to the expression, because this is where people get confused. That's already molarity, so this is at 4.8 times 10 to the negative 5th. This is going to be 4.8 times 10 to the negative 5th. Plug that in. When I go to do my expression, I always do the expression separately. So my KSP expression is going to be Ca2 plus, and that's going to drop right in, and then C2O4 2 minus, drop right in. So basically 4.8 times 10 to the negative 5th squared will get you your answer. So you end up with 2.3 times 10 to the negative 5th is my KSP value. Piece of cake. Next one. If I look here, go back up. Second thing they ask you to solve for is Bi3. They're telling me the solubility of it is 1.32 times 10 to the negative 5th. So I'm going to go Bi3, solid. I'm going to break it up into Bi3 plus 3I minus, right? When I do a mini ice table, this is what you got to pay attention to because the ratios will mess people up. 0, 0 plus S plus 3S. So I get S and 3S here. When they tell me the solubility is this, they're telling me S. So this is 1.32 times 10 to the negative 5th. So when I need to get this value, I have to do 3 times that. So what I need to do is I multiply it by 3, and I end up with 3.96 times 10 to the negative 5th. Because of this, I multiply by 3. Now, the second part I always do separate. I'm going to do the KSP expression. KSP is going to be equal to the concentration of Bi3 plus to the first power, concentration of, what is it, I minus cubed. I'm going to drop that value in there, and I'm going to drop that value in there, and then solve for KSP. You end up with 8.20 times 10 to the negative 19th. Look how small that value is. If you look, that's what we're talking about. When we say these things are slightly soluble, it is soluble on the small, minute level. And that's really what we're addressing when we talk about KSP values. Next one, 0.14 grams of nickel hydroxide, so they give me grams, is dissolved per liter, so we can find molarity with that. And again, they're asking us to calculate KSP. It's the same process, except I don't know what S is. So the first thing I'm going to do is I'm going to find S. So I'm going to take 0.14 grams of Ni parentheses OH parentheses 2. I'm going to divide by the molar mass of nickel hydroxide. So what I do is I take the 0.14 grams, divide by the molar mass, I convert it to moles. That's how many moles I have divided by 1 liter gives me my molarity. So that is my S value. That's S. The next thing I have to do is I'm going to write out the expression. So I'm going to take nickel hydroxide and I'm going to go Ni parentheses OH parentheses 2. That's going to be as a solid. It's going to break up into Ni2 plus 2OH minus. So when I go to do my mini ice table, it's going to be 0, 0, plus S plus 2S. And then at the bottom of my ice table, I'm going to have S and 2S. Now this is my S value, which means this is going to be 0.000015. This is going to be 0.0030 because I have to double it. The ratio on the E line is critical that you get that to solve the problem correctly. Then last but not least, I write my KSP expression. My KSP expression is going to be Ni2 plus, and then I'm going to have OH minus, and I'm going to have that squared. I drop the values in here. That's going to drop in there. So I'm going to go 0.0015 times 0.0030 squared, and ultimately I get my KSP 1.4 times 10 to the negative 8. Boom shakalaka. Next problem, last one, concentration of Ag plus. So they're telling me a specific ion. Makes me want to say con cuidado, which in Spanish is be careful, because they're messing with you. So the first thing I'm going to do is write the expression Ag2C2O4 as a solid. When it does break up a little bit, what we say pequeño amount, C2O4 2 minus, and then I'm going to do this 0, 0 plus 2S, S plus S, and then this is 2S, and this is S. Now, this is key. They're telling me Ag is 2.2 times 10 to the negative 4th. That's not S, that's 2S. So to get S, I would divide that by 2, which ultimately means it's going to be 1.1 times 10 to the negative 4th. You have to pay attention to the E line is the most critical thing because they use different ion ratios to mess with you. So then my KSP expression is going to be the concentration of Ag plus squared, concentration of C2O4 2 minus to the first. I'm going to drop that in there, which is going to give me 2.2 times 10 to the negative 4th, and that's going to be squared, and 1.1 times 10 to the negative 4th. Boom. I do the math, and I get 5.3 times 10 to the negative 12th. So make sure you know these. I may give you a small quiz at the beginning of the period just to check to make sure you're good on the expression. Solving. The key thing you always want to remember is the most fundamental part where people make their mistakes is the E line. Concentration of the ions is directly related to the coefficients. Do them separately from the expression, then drop it into the expression. Word.